And we're here. Right, so now on this video, I'm going to look at the Node.js, specifically at GraphQL, which is a new way of building frontend and backend. Uh, this is a new way of querying data. The beauty of this, at least with GraphQL, is that it allows us to see the relationship in our data and how each other uh, relate. So yeah, it's to see how all of the different pieces, which is what I'm doing or what I mentioned here, how all of the different pieces of data relate each other in your server. So with GraphQL, it all starts describing the data as schema, and if you want to query that data, you use GraphQL query to ask the data that you want. So this is much like selecting property on an object, and the reason of or one of the benefits of using these GraphQL queries is that since it allows us to select property or selecting property uh, like an object, and the result really match closely to what the GraphQL query is, and this give us predictability of what the result might look like, regardless how the data is stored. And okay, so with that, then I look at what is GraphQL and who made that, which was created by Facebook in 2012. Uh, and unlike the REST architecture, where you have multiple collections, and if you want to combine data, you need to make individual requests and to get individual response and filter out the data in the client side. With GraphQL, there is no need to do that. You only have one single entry point and you ask the data that you want. So I also look at an example of using GraphQL, this built-in front-end tool that allows you to write these GraphQL queries and also uh, test your GraphQL queries, and we use the this graphical. There you got it. What? The GraphQL. I think it's the name of this. What is this? What are you doing? Interesting. So yeah, so GraphQL playground. Okay. Interesting. Hmm. For real? Uh, this front or GraphQL online. This front end tool. Oh my god. Let me look at this. Jesus. What? There you go. There you got it. Graphical here's Rapid GraphQL. Exactly. So it's this, right? So this allows you to test your queries against someone that already create a GraphQL server that expose some of their features. So for example, interesting. No valid ID extracted from one. It seems like there is none. What about this? What if you want to only get the field? Because right now, what we can do is to check at the docs that expose that. Graphical docs. Looking for graphical docs. That's right. Uh, yeah, the way it where it is, I think must be here exactly. So here is exposing is all of the uh, capability that this GraphQL has. Where you have is the all films, okay, and so you need to pass is so here you define is so here you want from all field is the and there's some property you have to pass to that species and things like that. Oh, okay. Field ID and the field ID, which is one. What about this? If you click here, you can see is the data structure from this type, and the field that will contain is the title and the release date, right? But for some reason, there you go. So we got is from the first film, A New Hope, and it gives you is the title and release. And as you can see, is that the query really match closely the object that we get from our response, which is one of the great things of using GraphQL. However, the reason of there is a question here, and I wonder why do I need to use GraphQL if we can use, for example, RESTful, right? So because it solves couple particular problems, okay. Yeah, because it solves quite a couple issues that like no underfetching and no overfetching. So no overfetching mean is that the server doesn't no need to send additionally extra data to the client, and then on the client you need to filter out that data to show to show relevant data to the user. And I know I'm repeating a lot of myself here, but that's the whole idea of the overfetching. And the other is the underfetching. So the underfetching is that we lose time anytime we make a request to query multiple collections, thus increasing is the waiting long time and of course impact the user experience. So by only having one single entry point, you solve is the underfetching issue and the overfetching problem. Another the advantage is that since it provides schema and types, it speeds up the development. The trade-off is this flexibility, which is something here. So this flexibility adds complexity because now there's a new way of building APIs, and developers need to know how to interact with them, and they must be quite familiar. For example, with Ref, we already have catching methods that are already proven that are very, very good. Whereas in GraphQL, it is they have this new way of catching it that can be difficult, and ultimately it's not restful. So because the way how you make your uh, queries to the server is by performing an HTTP post verb, where once it hit the GraphQL entry point with the proper data in the body, then you get the data that you want. So GraphQL is being used in combination with RESTful, and there is in some scenarios there is a recommending approach, for example, using authorization. So what's more is that GraphQL makes it easy to migrate piece of your RESTful API to GraphQL. So that migration from RESTful to GraphQL uh, is quite easy, doing piece by piece, chunk by chunk. And to use GraphQL, you can use GraphQL in combination again with RESTful and elsewhere. So then I look at the GraphQL implementation. By looking at spec.graphql.org, here is very enlightening. The reason of why they create is GraphQL. There are it is a new query language unapologetically for the front end. Uh, and then I also look at the relay.dev, which are tools for um, interact with this GraphQL server using React, okay, and the Apollo GraphQL, which is a full-fledged applications that allows you to build front-end and back-end GraphQL server. So before I dive deep into what are the benefits of the Apollo, all right, on the course, we started to see how can we create a GraphQL in Node from scratch. So by using its Express and a GraphQL Express middleware in Node.js Node.js 14 version, okay. Uh, this uh, or this is the setting or how you can start building your first GraphQL server. And here by importing this GraphQL package to build the schema and all the schema or the type system from the GraphQL spec uh, that is used to describe is the capability of this GraphQL service. It all starts with the type query, which is the entry point for all of your GraphQL server. And below here we define is a root value for this. Okay, so you have is the type and what is the root value associated with it. It was pretty simple. It was pretty straightforward. I also tested that with Postman again by making an HTTP post and passing is the body with this JSON query and fetch me the description like this. So you're gonna query is to indicate what is the entry point of your GraphQL query, and fetch is the relevant data for that. In our case, description, right? And because we define that here as motorcycle, okay, yes, it fetch us here motorcycle, but here is you barely see it. So after I create my first Node.js GraphQL server, okay, and designing an e-commerce schema, again, this is to actually look beyond on what are the capabilities that GraphQL or where GraphQL shine, because deep nested objects, something that I did here, Visual Studio Code. Okay. So deep nested object. Once I create the GraphQL server to enhance is the capability to provide is these e-commerce features. So deep nested objects are very common in any e-commerce application or in any app with some technical debt. So which make them perfect candidate for GraphQL. And it is actually amazing how easy it is to query really complex data structure for exactly the data that we need. So our API is organized in types and fields rather than endpoints. So making or query multiple endpoints unnecessary to combine the data on the front end. Something that most developers are familiar with. And then you look at the GraphQL tools like this. So as our project gets larger, the reason of looking at this is once we create is the e-commerce, where in our case we already modularize our GraphQL, something that I'm going to explain later. With GraphQL, so as our project gets larger, so instead of keeping everything in one file, which is something that we did here, but as I mentioned, I already modularized this code. So instead of having all of the GraphQL type definition in one file for orders and products, uh, how do we break our schema into multiple files? That's one of the questions. And how do we structure our projects based on functionality? And this is a couple questions that even wrote here based on scalability. So I'm gonna make a pause here because since I look uh, through finance and business and technology, so the scalability concept is something that is important and crucial for any business. Why am I saying that? Alex Almosi mentioned that most businesses are worthless because they offer is tailored a solution to each one of their customers and they are unable to scale that, right? So if you have a product or if you have a business that can be scalable, where you can offer that to multiple people, hundred, perhaps million of people, okay? So as your project gets larger, so instead of keeping in the context of GraphQL, so instead of keeping everything in one file, so how do we break down our schema into multiple files? How do we structure projects based on functionality and organize our servers when we need to add more complex logic to fetch our data? So the first, it was pretty straightforward. What we did is just to define is the uh, data models using a .graphql extension. Okay. So how do we organize our types into multiple files? We create separate file for all of our main uh, or for all of our main types, right? Organize our server by features, and that will help us also. In our case here, we're defining some placeholder since we're not fetching any data from the database so far, but we're gonna do that. Uh, so that answer our first question and also structure our project based on functionality. This is so this answered this question by features here. Uh, so then once we did that, all right, we use something called is graph tool in order to make our application or modularized large GraphQL projects, since uh, large-scale projects are usually organized by features. So we can use GraphQL tools, and the way it works is that it can import different tools as we need it. So in our case, the first function that we need is to make the executable schema by defining the schema. And since here we pass this as an object where we're going to send the type array, great. And here, this is a function from the GraphQL tools load files that allows us to load the files and using a particularly regular expression to look out for all of our GraphQL synchronously, okay? Meaning that you're going to perform this operation and you have to wait for this operation to complete, okay? So the event loop in Node will have to wait for this operation complete until it goes and execute the next line of code. So here we are getting is all, so we're looking for in our root folder. Okay, in our root folder, we're going to look for all of the files which extension has GraphQL. And then once you have that string, and that's one of the beauty of this, because this is a string and you can compose as many types as you want, there is a trade-off because this particular approach is useful as long as there is a valid schema and there is no name conflict. Okay, so once you pass that array, here we are importing is using the require function using the common.js module resolution. And again, this is just for a placeholder for demo purpose. And when we run this, especially here, we're using is npm. We should use yarn or pnpm. I don't think we have. That's right, because we need to use the latest version. Okay, it's 14, version 14. That's right. Why 14? Because if you use, for example, newer versions, they are not compatible the Express GraphQL middleware with Express. So, and again, for demo purpose, we are using this version. Now, I can now run is the npm start code. So once I navigate to that, and I say, hey, I would like to navigate to this, especially to the GraphQL endpoint, here we are, right? When we asked for product and description, we get all the description for all of those products, which is red shoe and blue jeans. So once we look at this, at the product placeholder, which is here, product placeholder is that red shoes and blue jeans. I mean, this is the description, red shoes and blue jeans. Okay, so that actually works, okay? And the whole point of this is we create a GraphQL server that is modularized, that is scalable. Okay, makes sense. Makes sense. Now, so modularizing large GraphQL project schema. This is where we left our lesson. This is where we Okay. Very cool. It's going to continue. Yeah, this is Secret to Mastery. Thanks for that. And here I am looking for Node.js. Great. And holy moly. Mother. What the? Oh, jeez. Okay, here we are. With the resolvers. Okay. So after we organize our code in a way that can be scalable, aka meaning easy to maintain, all right? Now I'm going to look at this new topic, resolvers. Is here. Resolvers. I already saw the video, and this is the key takeaway from that. So every large-scale GraphQL server has two main components according to that, according to the Zero to Mastery instruction: schemas and resolvers. So we already know and we're quite familiar with what is schema, okay? Uh, but what are resolvers? The answer lies on what happens when we make a query. So far, it's actually kind of magic what happens. I don't generally know what it is or what's going on. GraphQL always determines if a GraphQL is valid. So yeah, so GraphQL always determines if a GraphQL is valid. Eagle hunt no flies. Eagle hunt no flies. So GraphQL always determines if a GraphQL is valid by looking at our schema and then execute it. Okay, so GraphQL determines if a GraphQL is valid by looking at our schema, and then it execute that query. When executing that query, the value of each field is determined by a function called resolvers. So resolvers is a function that determines the value of that field. Okay. And let's go to keep listening to it.
Welcome back. Every large-scale GraphQL server has two main components, the schemas and the resolvers. We know all about these schemas, but what on earth is a resolver? The answer lies in what happens when we make a query. GraphQL always first determines if the query is valid by looking at our schemas, and then it executes that query. When executing a query, the value of each field is determined by calling a function called a resolver. When a field is included in our query, the corresponding resolver is called to provide the value for that field. When called a resolver. When a field is included in our query, the corresponding resolver is called to provide the value.
Okay. So when a field is provided in our query, a resolver
For that query, the corresponding resolver
the corresponding resolver
is called to provide
the
value for that field.
It's called to provide the value of that field.
When the server has called all the resolver functions found in the query, it then wraps all those values up and sends them back to the front end, back to the client that asked for the data functions found in the query. It then wraps value for that field. When the server has called all the resolver functions.
Okay, interesting. When the server has called all the resolvers
Found in the query,
found in the query,
it then wraps all those values up and
okay, it then wrap all those values up
sends them back to the front end.
and send it back to the front end.
Back to the client that asked for the data in the first place. So why do we need these resolver functions anyway? What problem do they solve?
Interesting question. Why do we need these resolver functions? I'll argue that is because once you if you want to make some async operation,
So far, in our GraphQL code, we've been using these root values to determine what data comes back from our API. But these root values,
so the root value here, okay. So what are the problems? The problem it's solved. It's solved. Come on. What the exactly? Yeah, what are the problems it's solved? So the root value is the value.
we've been using these root values to determine what data comes back from our API.
So the root value determine what data come back to the.
In our GraphQL code, we've been using these root values to determine what data comes back from our API.
Comes back from our API. Exactly.
But these root values point to our models that contain hard-coded data, like our orders model right here, which isn't very realistic when we need to do an API call, a database query, or some other logic to get the data for one of our fields, one of these fields from our GraphQL schema. Instead of using these hard-coded root values, we use functions that we call resolvers. GraphQL calls all the required resolvers. We fetch the data that we.
So instead of using the root value, since it's not practical,
do an API hard-coded data, like our orders model right here, which isn't very realistic.
exactly, since it is not realistic. So instead of using the root value uh, that come from, so instead of using the root value So instead of using the root value that comes from exactly. So instead of using the root value that comes from our hard coded data, since it is not realistic, we need to fetch the data
when
from
we need to do an API fields from our call resolvers. GraphQL.
That's when we need a function called resolver. Exactly.
Calls all the required resolvers. We fetch the data that we need in our resolver function, and the data gets sent back to our clients. To update our code to use resolvers, we can use our
If we update our code to use resolver,
make executable schema function, which, in addition to our type definitions, which contains our schemas, we can also pass in a resolvers property. This contains an object with all of our resolver functions. For our basic queries, where we're fetching some data from the server, we add our resolver functions under this query property, which includes functions that match all of the root values of our schema. So products, which contains some function, we'll use this anonymous function syntax, and orders, which has its own resolver function. Each of these resolvers takes in some arguments with data that GraphQL makes available in case we need it. There's the parent, the args, the context, and info. When we're passing in some root values, the parent starts out as being that root object. So to return the product, when the product's resolver is called, we could just say return parent dot product, and the value from the root will be returned when GraphQL calls this product resolver. We can log that our resolver is actually being called, so we're getting the products, and now we'll know that this function is actually being used. All right, what about these other arguments? Well, args is used when we have parameterized queries. For example, when we want to filter our products based on some condition. We'll learn all about this in an upcoming video. Now, the context is useful for data that's shared across all our different resolvers. For example, if we want to pass down authentication data about which user is logged in to every one of our resolvers. And info contains some information about the current state of our operation. Because many of these arguments are only used in advanced cases, we'll often see them excluded from our resolvers. For our product, we only really care about the parent. The rest of the data is completely optional. Now, for orders, we could do much the same. We pass in the parent and just return parent.orders. And we can log that we are indeed getting those orders from this function. So getting orders. Now, if we run our server, npm start, we can go into graphical and execute a query. We're getting the same data as before, but it's now coming back through our resolvers. All right. So we're doing pretty much the same thing we were doing before, just with this added layer on top. But the beauty of this is that our resolvers can now make API calls or asynchronous database operations and combine different data or filter it. And that's the data that GraphQL will send back to our users. As a simple example, let's make our product resolver asynchronous. So it returned this promise, which we can create using our promise.resolve function that creates a new promise that immediately resolves to our product's data. GraphQL will now wait for this promise to resolve before sending the data back to the user. We could even make our resolver function async and use the await syntax instead, and say that the value from this promise goes into a products constant, which we then return back. Our server will still work exactly the same. We can restart our server, and back in graphical, executing our query now involves waiting for some asynchronous events. This is powerful stuff. Our resolvers can now do complex asynchronous operations to fetch whatever data we could possibly need. Now, you might be thinking, wouldn't it be nice to split up our resolvers, just like we did with our schemas, so that we could have our products resolvers next to our product schema and our...
Okay. Okay, so resolvers. That is resolvers. So resolvers are functions that are being called to determine the value of the type, and that happens uh, when GraphQL determines if a GraphQL is valid by looking at a schema and then execute a query. Okay. So GraphQL always determines if a GraphQL is valid by looking at the schema and then execute that query. And when executing that query, the value of each field is determined by a function called resolver. And when a field is provided in our query, the corresponding resolver is called to provide the value on that field. And when the server has called all the resolvers found in the query, and then it wraps all those values and sends it back to the front end. So I know what is a resolver. Okay? So the answer of what are resolvers lies on what happens when you make a query. So GraphQL always determines if a GraphQL query is valid by looking at the schema and then execute that query. So when executing the query, the value of each field to determine the value of each field is determined by a function called resolvers. Yep. Is determined by a function called resolvers. And the resolvers, well, provide the value of a type once the GraphQL validates if that query is valid and executed. So when a field is provided in our query, the corresponding resolver is called to provide the value of that field. And when the server has called all the resolvers it found in the query, and then it wraps with S exactly, and then wraps all those values, and then wrap all those values up and send it back to the front end.
Product model, and likewise for our orders, instead of having everything all in one giant resolvers object. After all, this approach here would get quite messy for more complex operations, or if we supported many more different types of queries. Well, those are some great points. Let's find out how to structure our resolvers and make things a little bit more modular in large GraphQL projects. I'll see you in the next one.
Modularizing large GraphQL
projects. How do we take advantage of our more modular folder structure that we introduced for our schemas? Just like we did with our schemas, our resolvers can also be loaded in based on some file path, thanks to this excellent load file sync function from our GraphQL tools library. Let's say that our resolvers are split up so that the orders resolvers live in the orders folder under a orders.resolvers.js file. Oops, and I need to make sure that's JS. And product has product.resolvers.js. We can now call inside of server.js this load files sync function to look for that file name pattern. So just like with our .graphql files, we're going to use the path.join function to look inside of the current directory, and we're going to join that with this file pattern that looks inside any subdirectories for a file that ends in .resolvers.js. We're going to take those resolvers and pass them into a resolvers array. This array can now be passed in to make executable schema in place of our resolvers object. We'll remove our old resolvers and just pass in resolvers array. Now, how would we write our resolvers in a more modular way? We know that we want to export from our module, so module.export, an object which contains this query property with all of our resolver functions for each field or query that we want to support. So for products, we'll have our products function, again using this anonymous function syntax, and in our orders resolvers, we'll have something very similar. We'll have a module.export with a query for the list of orders. The query object in our orders resolvers will be merged in with the products query resolver when we pass it in to our make executable schema. The result will be a single query object that contains both orders and products. Now, to get the list of products for our API, we could again use this parent argument and return the value from that, so parent.products. But we've already decided that's not very realistic. In large-scale projects, we would have a products model that contains functions like, for example, a function to get all products. And this function would make whatever API calls and database queries to get all the products in our e-commerce application. Let's use this pattern in our example here. Our array here is our in-memory database. So let's assign that to a constant that we'll call product. And our getAllProducts data access function in our model is taking our in-memory database and listing all of the products. So return everything in our products list. Our model will now export all of these data access functions to be used in our resolvers. So getAllProducts is our one export from the products model, and in our orders model, we'll do much the same. We'll set our list of orders and then have a function to get all orders, which returns everything in our in-memory database. This list we just made, let's make sure we're calling return, and then export that getAllOrders function to be used in the orders resolvers. So getAllOrders, which we can now import inside of this resolvers.js file. What we're going to do is const orders model equals require from the current folder orders.model, and now we no longer need to rely on the root values, those hard-coded values that we passed directly into GraphQL, but instead we can use our orders model and whatever functionality it supports to access our orders data. Now our resolver will return orders model dot get all orders, and regardless of whether that's an asynchronous function or a static value, the correct data will be returned. In GraphQL, the best practice is to keep your resolver functions as small or thin as possible and use the functionality in other modules or other models to do all of the hard work. Now we could completely change the implementation of our orders model to, for example, access a SQL database and fetch all of the orders from there. And as long as we keep this getAllOrders function, using that as the interface, as the way of accessing our data, well, our resolvers don't need to change. It's only the implementation of our model that needs to be swapped out. This is what we want our large GraphQL projects to look like. All right, so let's do the same for our products resolvers. In our products model, we have this getAllProducts function, and let's make sure we're exporting it correctly with module.exports and not module.export. There we go. Now in the products resolvers, we can import this function. So we'll say const products model equals require from the current folder products.model, and we're no longer using the parent, but instead returning from the products model all products. And there we are. Now in our server.js, we no longer need this root object, so we can remove that, and we no longer need to pass in these default values into GraphQL. Instead, the data all comes through our executable schema from each of our resolver functions that talk directly to our models. This is a much more realistic, real-life GraphQL project structure. This is also how I would structure my own GraphQL project. All right, our resolvers right now are super simple. In the next video, let's explore some practical use cases for resolver functions, where we pass in arguments and use those arguments to filter the data that comes back in our queries. It's going to be a good one, so I'll see you there.
Okay, I'm going to make a pause here For this one,
Back all
stop. I'm gonna take a break here.
large GraphQL projects. I'll see you in the next one.
Yeah, I'm gonna take a break here. Uh, so
It's go.
I'll see you soon. Take care. Bye bye.